Hello again, everyone. Welcome back to another episode of the Sun Devil Learning Labs conducted by Arizona State University. I'm your instructor, Michael Barker, for grade 5 math problems. Today we are going to be solving word problems that involve decimal and fraction multiplication. We call it Word Problem Wednesday. So our objective is to solve word problems with decimal and fractional multiplication. So before we start, I'd like to go over a few things with you. Our objective, once again, solve the word problems, decimal fraction multiplication, and a few things that I always try to remind people before they start just to make the lesson a little easier and go a little smoother. First, make sure that you are in a comfortable setting with no distractions. That means turn the TV off, any extra music in the background that might be going on. All noise like that should be out. You should also be in a quiet place. Someplace that maybe if you have a brother or sister that they're not distracting you or the dog's not running around being crazy. And if you need help with that, you may have to talk to your parents and explain to them you need a quiet place where you can focus and concentrate. Secondly, gather any supplies you might need today. I suggest a couple of pencils and a notebook. I hope you've been keeping a notebook as we go along. If not, it's not too late to start, or if you want to review it, because you never know. We sometimes hit this icon here, and when we have this icon, there's a reminder and it's something that's worth taking a note and keeping in your notebook. But if not, you should at least have several sheets of paper. Scissors and a ruler would also be helpful as well. And finally, be sure and use the restroom before we start. But remember, you can always pause the video if you need to take a break, or if you have to go back and review part of a lesson. Make sure you comprehend what you've been looking at before you move on, because our lessons always build on the previous parts. So if you don't really understand something, it's better to slow down, review it, and make sure you have a good grasp of what you're looking at. So Word Problem Wednesday. What do? We use the cubes model, and it's a model that we use when we write the problems, and you can use any version of this you want, but it's just something we use. We use cube C, circle key numbers. It's just, what do I know? We can circle them in yellow or highlight them in yellow. Sometimes it's just as easy when you're working on the computer to just highlight things, or you can highlight them at home if you're working as well, but circle or highlight what you know, pick a color. Then secondly, U, underline the question. What am I being asked to solve? I usually highlight that in red for us, and I'll try to underline it as well. And that's usually what is the answer we're looking for, what type of answer. B is box math action words. Am I going to add, subtract, divide, multiply, or something else? Sometimes it won't be very clear, but sometimes it won't say add or subtract. It may say like how many or all of. And you just need to infer what sort of math action you're going to take. Then after that, we want to evaluate the problem. What steps do I take? What information don't I need? A lot of times when we read a question, there'll be some stuff in there that really doesn't matter to solving the problem. It might make the story sound better, but it doesn't really have any consequence in the solving of the problem itself. And then finally, S, we solve and check. We ask ourselves, does our answer make sense? And sometimes we can figure out a way to double check, or we work with two different methods and just make sure that both methods of solving come up with the same solution. So let's move now to our first problem, and this is one I'll do together with you. And it's a Boy Scout has a length of rope measuring 7/10 of a meter, 0.7 meter. He uses 2/10 of the rope to tie a knot at one end. How many meters of rope are in the knot? Okay, so we've got some information here, and if we go and look at it now, we should be able to circle a few things. We know that the length of rope is 7/10 of a meter, and we know he used 2/10 of the rope to tie a knot at one end. And the question is, what we want to know is how many meters of rope are in the knot? Okay, well, we should be able to take a look here and see that if he used 2/10 and we draw a tape diagram, we want to break it up into tenths because those are the units that we know we can work with. That's a fraction that we can work with. And so we have 1, 2, that's the rope that was in a knot, and that would leave us with 1, 2, 3, 4, 5, 6, 7, 8 tenths. So we know we have 10 total tenths out of our whole unit. Our whole unit, our 10 tenths is equivalent to 0.7 meters. And we can put all that information down and then go to work. So let's ask ourselves a question again. What is the question? We want to know how much 2 tenths of 7 tenths is going to be equivalent to. Well, one of the ways we did do things was we turned to fractions sometimes and multiplied 2 tenths by 7 tenths. Numerator times numerator gave us 14. Denominator gave us 100. 14 100ths is our fraction. We do not want to simplify here because then we wouldn't be able to convert it to decimals as easily. So with here, we know 14 100ths can be written as 0.14. We can see it on our place value chart as well. There we have no whole units. There's our decimal. We have 1 in the 10th unit and 4 in the 100th units. So we've confirmed now with our place value chart that our solution makes sense. Well, you know, we can also use our shortcut method that we learned in a previous lesson, right? Let's take a look at our question again. 2 tenths multiplied by 7 tenths. What are our whole numbers? Our whole numbers are 2 and 7. So 2 times 7 gives us a total of 14. Now we have 14, and we know our factors had 2 decimal places, right? One here and one there. So we can't lose those decimals, but all we have to do is move to our answer of 14, start at the end, and work our decimals back 2 places, 1, 2. And once again, our solution is 0.14 meters. And now we still have to write our answer, our solution to a word problem in a sentence. And it's quite simply, there are 14 hundredths, 0.14 meters of rope in the knot. I hope this went fairly simple for you, and we won't get too much more complicated as we go on, but if you need to pause, now's a good time to pause and just make sure that you grasp what we've gone through so far. Okay, let's look at our second problem. This is about a boy, Lenox, running a race. Said after just 4 tenths of a 2.5 mile race was completed, Lenox took the lead and remained there until the end of the race. How many miles did Lenox lead the race? Okay, a lot of information in there, and we'll take a look at that when we move to the next part. And what do we know? We know that 4 tenths of a 2.5 mile race was completed. We know Lenox took the lead and remained there until the end of the race. So our question, how many miles did Lenox lead the entire race? Well, we can figure that out when we know, when we take a look at what information we already have. What do we see? We know our whole race, 2.5 miles, okay? And we're setting up our tape diagram again. And because after 4 tenths was completed, that's when he took the lead. Our fraction is going to be, our units are going to be tenths. So 1, 2, 3, 4 tenths. That'll be the remainder. There should be 6, 1, 2, 3, 4, 5, 6, because 6 and 4 would give us 10 equal units. And with that information, we can move forward and continue to try and solve our problem. Now, how are we looking at this? The question again, remember, how many miles did Lenox lead the race? So that was after the 4 tenths. So we want to count these units again. 1, 2, 3, 4, 5, 6. Those are the parts. 6 tenths of the race is the fraction that Lenox led. So he led 6 tenths of 25 tenths, right? Because 2.5 miles is the same as 25 tenths. We should know that by our fraction equivalence. So when we turn and multiply our fractions, it becomes 6 tenths times 25 tenths will give us a solution of 150 1/100th, or 1.5. And we know it's 1.5 because when we write 150 100ths on our place value chart, we have 1 in our unit place, and we're going to have 5 in the 10th place, and that'll be it. We could have put a 0 in there, but it's really not necessary. But we have 1.5 miles. Now again, we could have used our shortcut. I personally like the shortcut and I recommend it, and hopefully you'll get comfortable with it soon. 6/10 multiplied by 2.5, that's our whole numbers would convert to 6 times 25. That's equivalent to 150. Our factors had 2 decimal places, right? 1, 2. So we move our decimal back 2 places left. 1, 2. And our 1.50 is our solution. It matches our solution from when we multiplied fractions. So we can be pretty certain that we've got the right answer. And that lets us write an answer in words, and answer the word problem. Lenox led 1 1/2, or 1.5 miles of the race. And our next part of the problem is going to be a second part of that problem. And in this part, in the same race, Reid, the second place finisher, he developed a cramp with 3/10 of the race remaining. So how many miles did Reid run without a cramp? Again, we have to look at what we know, and that'll help us determine our solution. So what do we know? Well, we know it was the same race. So in the same race, we know the length, right? We know the length would have been 2.5 miles, and we can write that. That's going to be our whole unit. We know that. And our question, how many miles did Reid run without a cramp? So we know he ran 3/10 with a cramp, correct? So we would mark those 1, 2, 3/10. The last 3/10 of the race was when he had his cramp. But how many tenths did he run without one? Well, we should know this is 7, but we can count as well. 1, 2, 3, 4, 5, 6, 7. So 7/10 of the race, he ran without a cramp. So we know that 7/10 of 25/10 is going to tell us how much of the race he ran without cramps. So 7/10 times multiplied by 25/10 is going to be equivalent to 175 100ths. Again, when we write 175 100ths here, another method we can use sometime is when we see that, we can start with our hundredths, move our 5 in, then we move our 7 into the 10th place, we move our 1 into our unit place, and we're done. Our decimal always stays in the same place. That's the beauty of using this chart and having our column there. And so we know that he ran 1.75, or 1 3/4 miles without a cramp. And how about using our shortcut? I know that 0.7 multiplied by 2.5 is the same as 7 by 25. That's equivalent to 175. Again, our factors had 2 decimal places. So 1.75 is our answer after we move our decimal 2 places back to the left, and our solution is 1.75, the same as we got with our fraction model. And again, we have to write our answer in the form of a sentence. We know Reid ran 1 3/4 miles, 1.75, without a cramp. Okay, Word Problem Wednesday is really built on you guys doing some problems, and then we'll go over the solutions together. I'll read the problems to you, and then I'll give you, it'll probably take you 15 minutes or so to solve them all. There's, I think, 5 problems in total today. So it may even take you a little bit longer than that, but I'd say between 15 and 20 minutes. Our first problem, Jennifer makes 1.7 liters of lemonade. If she pours 3/10 of the lemonade in a glass, how many liters of lemonade are in the glass? The second problem, Cassius walks 6/10 of a 3.6 mile trail. How many miles did Cassius have left to hike? Third question, Erik buys 2.5 pounds of candy. If each pound of candy costs $7.70, how much will his total cost be? Another problem, problem number 4. This is going to be the first of 2 parts. The kitchen measures 3.75 meters by 4.2 meters. Find the area of the kitchen. You should remember your area formulas, and if not, we'll go over it in the solution. And in the second part, the area of the living room is 1 1/2 times that of the kitchen. Find the total area of the living room and kitchen. Now these problems, like I said, it may take you 15 to 20 minutes to work on them, but why don't you work on them, solve them all if you want. I'm going to go through the solutions one by one when we come back, and whichever way you want to work them, you can do one and then check, or you can do them all and then check. But I'll be back with you after a few minutes, and we'll take a look at the solutions. Okay, we're back. So our first question, Jennifer makes 1.7 liters of lemonade. If she pours 3/10 of the lemonade in a glass, how many liters of lemonade are in the glass? Okay, what do we know? We know she made 1.7 liters. She poured 3/10 of that in a glass, and we want to know how many liters of lemonade are in the glass. Well, our fractions, right? 3/10 is what my solution is going to look like. 3/10 of 1.7. We know that's what we're looking at. We can draw a tape diagram. I drew that over here, and I broke it into 10 units. We were working again with tenths, marked out 3, 1, 2, 3. And so we know 3/10 of 1.7, our total, is equivalent to 3/10 multiplied by 17/10 is going to be a solution of 51 100ths. And 51 100ths can be written in our place value chart as I start with my hundredths, 1. I move my 5 into the 10th place. And then I know I have 0. My decimal stays in the same column all the time. And I know my solution is 0.51 hundredths. Now we can also check it with our tape diagram, right? We know that each tenth is equivalent to 0.17. And so 3 times 0.17 is the same as 3 times 17 when we use our shortcut. 3 times 17 is 51. And our shortcut tells us, what, 2 decimal places. We just move our decimals over 1, 2, and we have the same solution, 0.51. So there are 0.51 liters of lemonade in the glass. And hopefully you had a solution that looked like this. And like I said, there's more than one way to get there. Whichever way you're comfortable with and works for you is fine. Problem 2, similar to the first problem. Cassius walked 6/10 of a 3.6 mile trail. Now the question is, how many miles did Cassius have left to hike? A little bit different than the first problem, right? First problem wanted to know how many we put in there. This time we're going to ask how much is left. But we can still do it in a couple of different ways. I drew a tape value chart, and I knew that, again, I first put our overall units, 3.6 miles. And then the question was, he had walked 6/10. So I was able to mark 1, 2, 3, 4, 5, 6. 6/10 is what he had hiked so far. So they wanted to know how many miles did Cassius have left to hike. Well, we know that he had 1, 2, 3, 4/10 left. So now we can go back and we have our fractions. 4/10 of 36/10 is equivalent to 144 100ths. Again, I have a place value chart ready to go. I start with my hundredths, 4. Then I move my other 4 into the tenths, move my decimal down, and then I place my 1 in my 1 unit, and it should be 1.44 or 1 44 100ths. But let's check using my other shortcut method. We know 4/10 multiplied by 3.6 or 3 6/10 is the same. What are our whole units? 4 and 36. 4 times 36 is 144. We can count our decimal places, 1, 2, what do? We move our decimal 2 places back to the left, and we wind up with the same as we had when we just multiplied the fractions. 1 44/100ths of a mile. So we can say when we write our solution in words, Cassius still has 1 44/100ths, 1.44 miles left to hike. Okay, problem 3. Erik buys 2.5 pounds of candy. And if each pound of candy costs $7.70, how much will his total cost be? Well, this time a tape diagram I wasn't too comfortable with. Plus, we know a few other methods that we can use. We know that he bought 2.5 pounds and that there was going to be $7.70 per pound. So we can, again, convert these into fractions. 25 tenths multiplied by 770 tenths. I'm sorry, 77 tenths. We shouldn't have had that 0 there. But either way, we wind up with 19,250 100ths. So when we have to go down to our decimal places, we know our 0 can go into the thousandths place because we didn't really do that, but 5 hundredths, 2 tenths, then we had 9 in the 1 units, and then in the tens place we have 1. So we wind up with 19.25. Again, I like to look at it by simplifying it with the other method and just using our whole numbers and moving our decimals. 25 is our whole units, multiplied by 770 is going to give us a total of 19,250. Again, we move our decimal 3 places. We have 2 there and 1 there. 1, 2, 3. So we've moved 3 decimal places. Our solution again, 19.25. And so we know our answers are the same. The total cost of the candy is $19.25 when we write the solution to the word problem in a sentence. Moving on. The next problem. A kitchen measures 3.75 meters by 4.2 meters. And we have to find the area of the kitchen. Well, we know area is length times width. And so all we have to do is multiply our 3.75 meters by 4.2 meters. And again, we can take 3.7 meters multiplied by 4.2. If you want to change them to fractions, it's 37 tenths multiplied by 42 tenths. And that gives us a total of 1,554 100ths. What do? I move my 4 to the 100th place. There goes the 5 into the tenths. This first 5 goes into our unit numbers, our ones, and then this 1 here will wind up in the tens place. So we wind up with 15.54 as our solution when we use the fraction method. Let's try my shortcut method. 3.7 becomes 37, and 4.2 is going to be multiplied for 37 times 42. Again, 1,554. We move our decimal back 2 places. We wind up with 15.54. So the area of the kitchen is 15.54 square meters. Okay, that's the answer to our first part of the problem, how much find the area of the kitchen. But now our second problem, things get a little more interesting, don't they? It tells us the area of the living room is 1 1/2 times that of the kitchen. And now it wants to know the total area of the living room and the kitchen. So we got to do this in a couple of steps, I think. And I imagine you recognize that, but I wrote up in a corner here just so the kitchen was 1,554 meters squared. And we know that. But now we know the living room is 1 1/2 times the size of the kitchen. So simplest way to do that is multiply 1 1/2 by 15.54, our kitchen area. And what do we come up with? Well, that's 15 tenths times 1,554 100ths. That's going to give us a total of 23,310 1,000ths. So again, I moved the 0 into the thousandths place, the 1 into the hundredths, our 3 into the tenths, our next 3 into the ones units, and then the 2 into the tens. And by using this method, multiplying the fractions, we wind up figuring out 23.31 square meters is the area of the living room. Now, we can also use my shortcut method. 1.5 multiplied by 15 by 54 hundredths is the same as 15 times 15.54. And that would give us a total of 23,310. Again, we have 1, 2, 3 decimal places. So we move back 1, 2, 3. And what do we wind up with? 23.31, the same that we had up here. And so now we know the area of the living room is 23.31 square meters. Now, a lot of you might think you're done. You found the area of the living room and the kitchen. But let's go back and check our question. It was wanted to know the total area of the living room and kitchen. Hopefully you caught that. And because you had the area of it's 5 and it's 3, our decimal is going to stay in the same position. So our combined area is 38.85 square meters. Hopefully your answer looks something like this. Again, you may have used a few different methods, and that's okay. But I think you're going to find the shortcut is going to become a little easier the more you get comfortable and get away from drawing tape diagrams and dealing with all the fractions. And that's going to really conclude our lesson for today, decimals and fractions. And until we meet again, thank you and have a good day.